I wonder if we have a KSP lab.
Well, funny you should say that, Mr. Moore, because we do
Oh.
have a KSP lab. I know that's putting a smile on all our students' faces as well.
Mm-hmm.
Yeah. Yeah, this is, well, you can see up here, we're trying to use a titration to determine the silver ion concentration. But what you have to, the way you have to think of this is, the silver ions are being created by this sparingly soluble salt, Ag2X. Right, so you have to realize that, you know, Mr. Moore and I took a bunch of this salt, Ag2X, dumped it into a beaker, stirred it like crazy, let it sit for a long time, developed the equilibrium, and then we poured off the solution to use to be titrated in this lab.
Mm-hmm.
Right, so you're actually titrating the silver ions that are in solution, but those silver ions came from this salt Ag2X. And there's a lot of possible identities for X. X is some -2 ion. It doesn't matter to you who X is. Right? That is not part of this at all. You're just ultimately trying to find the KSP value for this salt. Okay?
Mm-hmm.
So now, here is the titration reaction. Okay, we're going to put some thiocyanate into the burette. Okay, and of course, whatever's in the burette, you have to know the concentration of, and it is 0.0100 molarity. And so, the silver ion and the thiocyanate ion get together to make AgSCN, which is a white precipitate. So what you have to be able to do then is know where's the end point for this, right? When have I added just the right amount of when have I added just the right amount of thiocyanate to match the moles of silver?
Mm-hmm.
Okay, so we're going to use an indicator to help us with that. All right, now the thiocyanate makes a white precipitate. So if you go past the end point, the farther and farther past the end point you go, you know, you're seeing this white precipitate, but what you want to know is when do these moles equal each other? And so to use as an indicator, we're going to have iron +3 ions. Okay, now this is a different reaction. This is the indicator reaction. The iron +3, that is our indicator, when it reacts with SCN-1, it makes this ion that has a red color, kind of a brownish red color. So the whole idea is you start out with your saturated solution of Ag2X that has a silver ion in it. We'll measure that out. We'll put in 6 drops of the indicator, and we'll start to titrate, okay? And so the silver ion and the thiocyanate ion, they get together to make the AgSCN. That happens first. But as soon as all the silver's been used up and it's gone, then the iron that's there reacts with the thiocyanate to make this, and you start to get a red color. It's a little bit of a tricky endpoint because you'll see it's going to sort of look like a milky white color from the AgSCN. We're looking for when that first hint of red starts to show up. So it goes from being white to kind of a dingy red color. It's a little bit of a tricky endpoint. But as soon as we see this red showing up, that tells us to stop titrating.
So the silver and the iron will be in there together. The silver gets together with the thiocyanate preferentially before the iron will. So we'll use up all the silver and then the iron gets its chance to react.
Right, that's right. It's kind of like a battle for thiocyanate between silver and iron. Silver wins until it's gone.
Until it's gone.
And then the iron is left to react.
Okay, do you have that concentration of thiocyanate?
Yep.
And let's go run this titration.
Run some titration.
Last titration of the year, Mr. Hubble.
I believe it is.
Yep.
Normally I have Kleenex out because students are crying.
Yes, I know. Just say goodbye to the burettes. It's a sad day. Ag2X sample number 4.
Yep. Here we go. Mr. Moore's measured out 10.0 milliliters of the Ag2X saturated solution.
Oh, good, so Mr. Moore does something.
Mr. Moore does most of this, to be honest with you.
Yeah, if you're counting the cheerleading.
Okay, after years of careful study, we figured out 6 drops is the magic number of indicator. 1, 2, 3, 4, 5, 6. Okay, this is the Fe plus 3 indicator. We got the burette full, so we're right at the 0.0 mark. Hopefully you'll trust us on that. And here we go. And so as we start in,
So we've done a trial of this already. We have an
Yeah.
idea of how much it's going to take.
yep. So we can kind of go fast in the beginning. You see how it's kind of looking milky white right now. That's the AgSCN precipitate. But when the silver's gone, it's going to start to look off-white because we'll start to mix some red in with it.
Oh, I think that was it. That is it.
Now it's gotten clumpy looking.
I was thinking it was kind of going brown. It at some angle it's
I
kind of
know,
brown.
what's hard is it's hard to tell sometimes. I guess that's it.
Yeah.
When you put it down on the table, it looks white. You hold it like this, I can see a brownish tinge to it. Like when I look at it here, it still looks white.
Yep, it
somewhat.
does. Yeah.
Does it look more brown than it was? I would say, let's go for it.
Yeah, I think that's brown enough to call that brown.
Yeah.
This is a tough endpoint. When you have other students in the room doing this at the same time, it's nice to compare your color to others so we get a better idea of how close we are. I'm not quite focused on that. There. Remember how we read that burette. All right.
Okay. Okay, let's run a second trial here. Okay, so there's 10.0 milliliters.
Oh, hold on, put that in the flask.
Oh, yeah. Good.
That's when we get doing this 20 times.
Yeah. Okay, let's try this again. 6 drops. 1, 2, 3, 4, 5, 6. Okay. And of course, the final burette reading for trial 1 becomes initial for trial 2. Oh.
What do you think?
It's close. I believe that's a little less than we used the first time.
Okay.
But it definitely has a brown.
Yeah, I
tinge to
think
it.
there's some brown. Okay. Hopefully these are close enough to each other.
Yeah. That's why we have to do at least 2 trials and take an average, because the endpoint is not exact.
All right. So we can determine that silver concentration.